but I'm not going to slow down for the notes, okay? All right. We're going to be talking about lenses. So our standard is develop and use model. We're going to start over because it's not on the screen. That's what stinks though. I have to like. There we go. Okay. Take two. Okay. All right. We're going to be talking about lenses. Our standard is develop and use models to demonstrate the effects that lenses have on light, such as formation of an image, and their possible technological applications. So the very first thing we have is a Bill Nye video. Obviously, I don't own the rights to this video, but I'm going to play it. It's about 5 minutes long. Light man, hit the lights.
Bill Nye the Science Guy. This magnifying glass is making my eye look big. Now, why is that? Please consider the following. When light enters something like air, water, glass, or plastic.
She said stop. Right? I'm gonna try that again. Good night looking at me like, why? It's like, and now you're smarting.
So maybe today you are unsmarter with Carter. So I'm going to turn the volume down before we start. All right, ready? Here we go. Volume is down a little bit. Not the setting button. Okay. We're going to start that over now. You know what? Just for you, I'll leave that on there so that, you know, there's.
You should plus all your bloopers. Like
I should have a blooper video. Oh, my goodness. All right. You ready? Take three. All right. We're going to be learning about lenses. Standard. Develop and use models to demonstrate the effects that lenses have on light, such as the formation of a light or an image, and their possible technological applications. We're now going to watch Bill Nye the Science Guy yet again. It's not the full video, just 5 or 6 minutes. And again, you know, just in case anyone out there in cyber world cares, obviously, I don't own this video at all.
Bill Nye the Science Guy. This magnifying glass is making my eye look big. Now, why is that? Please consider the following. When light enters something like air, water, glass, or plastic, it slows down a little. And when it slows down, it changes direction. See how one eye is lower than the other? See? Take a look at this. Here are 3 straight beams of light. When they go into the piece of plastic straight, they come out straight. But if the plastic is tilted, the beams of light get tilted. See, they change direction, so they come out this side offset. Now, what would happen if the piece of plastic didn't have straight sides, but had a curved side, like a magnifying glass? Well, light would change direction, right? Because the surface of the plastic is curved, each beam of light enters the piece of plastic at a slightly different angle, and it changes direction a slightly different amount. Look, over here the beams of light come together at a single point. This is called the focal point. Now what about the magnifying glass? Well, suppose your eye were over here, and light from the room were bouncing off of your eye and going through the piece of plastic this way. Well then, the small area at this end would be spread out over a large area on this side. Your eye would be magnified. Thanks for joining me on Consider the Following. The way a lens is curved affects how it bends light. See, the light from this candle is going straight into this lens. But because the sides of the lens are curved, the light gets bent. So look, down here we have a blurry patch of light. So move the screen in. Right here, at this point, that's where the candle flame is in focus. But look, it's upside down. It's all caused by the sides of the lens being curved. Now, if a lens is curved in like this, we say it's concave. Now, concave lenses make things look smaller and farther away, like they're in a cave. Okay? Okay? Ha! Now, if the sides of the lens are curved out like this, we say it's convex. Convex lenses make caves look bigger. Oh, I messed that up. They make things look bigger. That's right. That's it. The convex lenses, where the sides get bigger, they make things look bigger. That's it. That's what it is. Now, you have convex lenses with you all the time. They're right here in your eyes. Ooh. Anyway, convex, concave. Like a cave, like a vex.
Sandy said he could always remember concave by thinking of a sort of a cave, hollow. Convex is the other way.
Hi, I'm Ken. This is my partner, John. We're Penn and John. Do you ever, I don't know, look at yourself in a spoon? Well, if you look at yourself this way, your right side up. But if you look at yourself this way, you flip upside down. Why is that? Well, let's look at the spoon sideways. See, the upside down way, the light waves come in, bounce, and cross themselves, making you look upside down. See? Whoa, 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 whoa. The science guy.
All right, so what's a lens? So basically a lens is a piece of plastic or glass. It's basically a piece of plastic or glass that is used to refract light, okay? And depending on, and these are plastic, and these are ones I used to teach because it's, you can see the shape of them, but these are ones that are going to remind you of what? Like eyeglasses or monocle. Oh, I want a monocle. That would make cool. I want to have a monocle. Yeah, and then you can call me Dr. Monocle. All right, so, yeah. I don't know. If you can be the science guy, I can be Dr. Monocle.
You could.
I could, yes. Okay, so this is what they're gonna look like, but this is really hard for you to see what the shapes of these because this one is convex and this one is concave, but it's hard for you to see that from there. And right now, I'm not passing these around, so I'm going to show you with the larger ones. Okay, so this one right here is convex. We also call it converging. We call it converging. What does con mean? To come together. What does diverging mean? To spread apart. You know the movie Divergent? She's different from everyone else. So this one is divergent. It makes it, it's diverging because it makes the light rays come apart. And this one is converging because it makes them come together. So I'm going to show you that. But before we turn the lights out again, I'm going to show you the three things I'm going to use. One is the convex lens. And so think of it this way. Now, I can call the lens fat because it has no feelings, okay? But this is fat. So just think she's vexed. Vexed means word. She's vexed because she's fat. All right? Or not vexed. It doesn't matter. But convex is fat. All right? And concave, concave caves in. You guys see that? Okay. I'm also going to show you my little mirror. So I have this piece of metal. And depending on which way I turn it, so which way is this? Concave because it caved in, and this way is convex because it's fat. Okay, so what we're going to do is we're going to turn the light out again, and I'm going to have my lovely assistant Asia come up here. All right, and she's going to hold this. I'm going to turn this screen off so that we can get rid of the light, and Lightman's going to turn the light off. Thank you, Lightman. Okay, so you're going to hold these, and you're going to stand right here. All right, and I'm going to turn this camera this way. And I'm just going to make sure that we can see it. So I'm going to do this. And you're going to hold this against the wall right here. And actually, the more your body shadows it, the better. So like if you're creating a shadow, as long as you're not blocking the camera, you are. There we go. All right. All right, my lady. Can I move you that way, little coffee child? I still love you. I'm not ejecting you.
You just don't want the occasional coffee. Like this.
Hey, it'll just make people remember, other than the mask, it'll make them, not that you have COVID, but it'll just remind them of COVID times, you know, we're coughing and we're wearing masks. Okay. Yeah. All right, so now I'm going to move hold it out a little bit in front of you. Yeah, so you can see it on the screen. Okay, so watch right here. I'm going to start with the convex. That is the one that is converging. And if you can't see over there, you're welcome to walk over here because this is the darkest we can make it. So watch the lights. So right now we have lines of light. So when I stick this here, watch what it does. You guys see that? So what it does is it brings it to what's called a focal point. And I can move it this way to make it a little more emphatic. Okay? So it brings it to a focal point. I can move it out and it's going to make it come out here. But you see the lines are coming together. So that's the one with fat sides, converging or convex. And you can remember this. So what's the last letter of convex?
X.
X. And what does an X do in the middle? Comes together. So guess what? Convex comes together. Okay? Now, concave, when I stick it there, watch what happens. You guys see it? Okay? They spread apart. They spread apart. It's like if you fall to the bottom of a cave, your body's just going to, never mind. That sounded violent. All right. We'll just have to edit that out. Maybe people won't listen to the whole video. Okay. So there you go. Whatever it takes to remember it, right? Okay. All right. So now I'm going to show you the mirror. Is your arm tired yet? Good. All right. So now I'm going to show you the mirror. I'm going to start with the convex side. And I want you to watch. Now, this one's a little harder to see. So I did take a picture with my phone that I can show as well because it's just kind of hard to see. It's minimal, but watch right here. It's actually pretty cool, but it's hard to see. You see it spread out? So now what's happening? It's the opposite. It's the opposite. It's directing it back this way, but see them spread out here. I can tilt it some. You see that spread out? So what happens is the convex mirror does the opposite. Well, think about that. When you look in the mirror, you're seeing yourself opposite, kind of, right? So just think, if you learn the lens part, the mirror is the opposite. So for the convex, it's going to spread out. Okay, so there I can show the lines going. Okay, now for concave, that was the one that looks pretty nifty. Concave, can you see it? It's really, really hard to see because it's so teeny. But right here, and this is one, lean back just a little bit that way and see if we can see it. This is the one I'll show you a picture of. But what it does is it brings the focal point back to the center right here and brings it in. So it's literally the opposite, okay? Thank you, helper. Lights can come on, and I'm going to show you guys when the lights are on. So just turn it off when I do that. Okay? All right, have a seat for me, please. And I'm going to show you guys on my phone the picture of this one. So here is a good picture where you can see, and all the other pictures of my phone. But see, you can see where it comes together. And I will show you guys, if you want to in a little bit, those come together. So now I'm going to go this way and turn this back on. Okay. And go back to the lesson. It'll take a second to load up, and I might have to, while it's loading up, I will take a second to walk around and show you guys the image. You see how it comes together in there? The little lights in the middle. You see it? That comes together. Technology at its finest. I should play some Jeopardy music in the background during this time. For the background of the video.
Yeah, y'all should subscribe.
Oh, you not had to change my name again. All right. There you go. All right. You guys like Mr. Cute. You put all the Jeopardy music together, but now it's too late. Okay. So we're going to go fast right here. Here's the image that you need to make sure it's in there. So it hits this, and 4 lines is plenty if you haven't drawn it already. It goes through, and it comes together at a focal point. Also, then it comes back out. You didn't see that up there, but what it does, then it comes back out, but it looks kind of like an X right here. Well, not kind of, it is. So just remember, convex comes together in the middle. The lines come together. Okay? And then convex are, obviously, they're thicker in the middle and thinner up top. Okay? And they're used for magnifying glasses. They're used for telescopes, eyeglasses to help people see up close, and the main lens in a camera. So those are 4 examples of how these lenses are used. Concave Now, here's what's cool about this. So concave, what happens is the light waves go in, they spread out, and the light waves never come together again. So because they never come together again, they're not forming a real image. They're actually forming a virtual image. A virtual image. So these are a virtual image because the light waves rays are never meeting. Here's an example of that. Okay. Lights go in and they spread out. So your big focus here are these green lines of them coming in. Your focal point is out here. It's not coming in the middle. All right. They are thin in the middle, thick up top. Okay. They cave in on the side. These are used as eyeglasses to help people see far away. So if somebody has glasses and you get really close to them, you might can tell whether or not they can see up close or far away by looking at their lenses. Probably not. They're also used for cameras.
Try that on me.
Or you can just pop your lens out of your glasses. And yes. Do what? I should try that with the light. All right. He popped his lens out of his glasses. So, all right. Listen, it's better than the kid who popped his eyeball out when I was in science in ninth grade. It was a glass eye. He popped it out because he didn't want to take the test. So he let his eye fall out and said, I have to go because my eye fell out. And so he got out taking the test. So, yes, promise. All right. So, man, this video is going to be all kinds of full of awesome. Wonderful, right? This is what happens. And this is what happens when you're teaching the gifted class. You never know what's going to come up. Okay. It's used for flashlights, lasers, and door peepholes. Okay. Okay. Now mirrors. This is really just kind of an overview. We don't dig super deep into these lenses. We do look at some of the technological advances with it, or not advances, but things you can use it. This is a really quick video of the convex and the concave mirrors. So I want you to watch this. Likewise, I do not own. So you can turn the.
Convex and concave mirrors can be just as useful as lenses, solving many of the same problems. Let me show you how they work. Convex mirrors reflect light outward, resulting in an image that will always appear upright and smaller. You may have seen these kind of mirrors in a fun house. Here, the vertical is undistorted, making the horizontal view skinnier. Concave mirrors reflect light inward and can be used to focus that light. The focused light can be used to generate heat. The concave mirror can also be used to project an image. Notice that this image is always upside down, and because it's formed in the real world, we call it a real image. When the object is within the focal point of the mirror, the image in the mirror appears upright and magnified. Perhaps one of the most important uses of a concave mirror is the reflecting telescope. Not only do these telescopes provide high magnification, but they also solve a major problem that all lenses have. When light passes through a lens, there will always be a dispersion of colors, the prism effect. This can cause a blurriness which is hard to correct for. It is called chromatic aberration. Mirrors don't have this problem. Therefore, these days, most of the best telescopes are using concave mirrors rather than lenses. These include Caltech's Palomar telescope, the Keck telescope in Hawaii, and the famous Hubble telescope orbiting the Earth in outer space.
All right. So here's our mirrors. And tomorrow we're going to do a lab, and we're going to do it as COVID safe as we can. So there might be a lot of instruction for me where I show you, but we're going to do like a bit of a lab. But we talked about the mirror. And so for the concave, it's bulged inward, and it is an upside down or inverted image, but it's real. And then it can be smaller or larger depending on, but convex is the bulged outward. Okay. It's the virtual and upright image. Okay. And that's because on this side, the light waves go apart. They never come together. And that's why it's a virtual image. And these are going to always appear smaller. Check out your car window where it says objects in mirror are closer than they appear. Okay. Yeah. So, but mirrors, yeah. So we're going to look at different ways that convex and concave mirrors are used. So So what this whole purpose today is just to introduce you to convex and concave lenses and mirrors. So hopefully you had a nice overview and, lots of video mishaps today, but that's okay. We're just going to go with it. And all right. And now you are
Dismissed.
smarter with Carter. All right. You're not dismissed. You must stay forever.
Do you have like music